What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. 3.10 says a metal part, object 2 is hanging by a thin cord from a floating wood block. Object 1, the wood block has a specific gravity of 0.3 and dimensions of 50 by 50 by 10 millimeters. The metal part has a volume of 6,600 millimeters cubed. Find the mass M2 of the metal part and the tension T in the cord. Temperature of the water is 15 degrees Celsius. So let's write our goal. It's always the first step. Our goal is to find M2, so the mass of the second object, and the tension in the cord. And tension. We're given specific gravity of object 1 equals 0.3, which is the wood block, I believe. Yep. And then we're given that the dimensions of the wood block, I'm going to put WB wood block, the volume of the wood block is 50 by 50 by 10. The metal part, put volume of M for metal, 6,600 millimeters cubed, and then it tells us that temperature equals 15 degrees Celsius. Therefore, specific weight of water will be, because we will need the specific weight of water to do this. So I'm gonna go ahead and write down 9,800, and I get it from this table in the textbook. 8.5 says water at 15 degrees, 9,800 newtons per meter cubed. Okay, so first things first. Oh, let's write our assumption too. We're going to say that the cord is weightless, right? So that will help us. It didn't give us any information on that, so we're just going to assume it's weightless. It says it's thin, so we're just going to assume it's weightless. That'll help us solve this problem. It's probably unsolvable if it did have weight, just because they don't give us information about it. So let's find out the specific weight of the wood block given our specific gravity. So we know a specific gravity formula is the specific weight over the specific weight of water. I'll write it out. Of water at 4 degrees Celsius, which, let's rearrange this to solve for the specific weight of the wood block. It gives us the specific gravity, 0.3, and then water at temperature of 4 degrees Celsius, the specific weight of that is this, 9,810. Oh, no negative, put a fraction. Okay, put that in a calculator, you'll get that the specific weight of the wood block equals 2943. Okay. And then we're gonna have to use buoyancy. So I should have explained this problem a little bit. So this is a wood block and it's floating, and there's a cord connected to it that's holding up this metal object. It's floating because of the buoyancy force, so we will have to use that formula. So if we think about the buoyancy force, I'll write it small right here. The buoyancy force is the specific weight times the volume of that D is for displaced, like the volume that's underwater, displaced underwater or under the liquid. So we need to go ahead and find out. We know that this metal piece is fully submerged, so we already know the volume displaced of that. Or we know that the whole thing's displaced. We need to figure out how much of this wood block is displaced. So let's go ahead and do that. Volume displaced of the wood block equals, instead of writing WB and stuff, I'm just going to write 1. So 1. So 1 is the wood block and 2 is the metal part. So it says it's 50 by 50 by 10 millimeters. So that means the only thing that we need to count that will change from the dimensions that's displaced is the height here, is the width. Yeah, so it will be 50 millimeters times 50 millimeters, and then the height, so it's 10 millimeters is the whole thing, but only, and then 2.5 millimeters of it is above the water, so that means we have to do this to find what's displaced, right? So it actually be 2. I wrote the wrong. It's 2.5. And then put that in the calculator. Why did I put it in my notes? Let me calculate it out real quick. .18750 millimeters cubed. And then let's go ahead and calculate the volume 1. I'm just going to calculate this 50 times 50 times 10. So this is just the regular volume of the wood block. And that is 25,000. Let's go ahead and convert that to meters cubed. I think you multiply it by 10 to the negative 9 to convert it. So we'll have that this is 2.5 times 10 negative 5 meters cubed. This is 1.87 5 times 10 negative 5 meters cubed. Okay, so these will be useful later. Just going and solving that out. Okay, so let's create an equation for the wood block. So this is the steps we're gonna do. We're gonna say let's create step 1, find equation for wood block, which is 1. I'm gonna write as 1. And then step 2 will be equation for metal. Let's create an equation for that. And once we create these two equations by drawing an FBD for each one, free body diagram, we'll be able to use those equations and relate, and then be able to solve for mass. So these are the steps we're going to take for mass of the metal, so M2. Okay, so step 1, let's write an equation for the wood block. So here's our wood block. Let's think about the forces here. So we got the buoyancy force of block 1, or the wood blocks of 1, and that's the only force going up. And then we have going down, you have the force of tension, right, and that rope, that cord going down, tension always faces away, so we got tension facing away, down, and we also have the force of weight, right? So those are two things. So you do think of statics, get buoyancy force is positive, minus tension minus weight equals 0. So then we get that tension equals, we're going to be solving this for tension. Once we can solve for tension, and then doing that, we can plug this tension value into this equation for the metal block that we will solve for later, and then we'll be able to solve for mass 2. What am I missing? The buoyancy force, or no, the weight. It's minus weight. Okay. So let's do a little side note. We need to solve for tension. We gotta know what the buoyancy force is, and we gotta know what weight is. So on the side here, we know that weight equals mass times gravity. Let's make this a little bit easier and rewrite this, so we know that we can actually rewrite this as weight equaling the specific weight. In this case, it's water times volume, right? This is the same thing. And yeah, and then of the entire wood block, right? So put 1 right there. And then we know that, I should probably explain this a little bit. Okay, I'll explain this a little bit. So we know the density. We know that density equals mass over volume, right? I'm just explaining how I got to this point. These are equivalent. I just rewrote it a little bit. So that means using this density formula, we know that mass equals volume times density. So if you plug this back in, so say weight equals volume times density times gravity, and then we know that density times gravity is equal to specific weight, so that's how I got there. Okay, now let's solve for the buoyancy force. So buoyancy force equals the specific weight of the liquid, which in this case is water, and then we need to multiply it by the volume displaced of the wood block. Okay, now that we have our formulas here that we know, let's go ahead and plug these numbers in and plug it into this equation here. So that tension equals, let's do force of buoyancy first, so we know the specific weight of water, which we said is 9,800 newtons per meter cube, multiplied by the volume displaced of the wood block, which we put that it is 1.875 times 10 to the negative 5 power meters cubed. And then we got to minus it by the weight, subtract it. So it's the water again. And then the volume of the entire wood block, he says 2.5. I've just been plugging in everything we've already solved for. You can't see it. Put that in your calculator, you get that tension is 0.11 newtons, okay? So that's part 1 of the question solved for. But now we have tension, we got to find the mass of the metal. So let's go ahead and write, this is our step 2, right? Find equation for metal. So let's do another free body diagram. This is what the metal piece kind of looks like. And then we have the cord. Remember, we have I'm drawing the free body diagram. We have the cord going up. So we got tension And we got the buoyancy force again going up, and then the only thing coming down is the weight. So if we write an equation for these forces, we know that in equilibrium that these are, let's see, we know that tension plus, these are both going up, minus a weight equals 0. We're trying to find mass here. We know that mass is inside of weight. So we're going to try and find this weight force. So we're going to solve this for weight. And then once we solve for weight, we can use that to solve for the mass by dividing by gravity. So we get weight equals buoyancy force plus tension. We already solved for tension. We already know what tension is. We need to solve for the buoyancy force. So buoyancy force, and I should have been putting a 2 here, 2 for the metal. So this equals the specific weight of water times the volume displaced, which the whole thing's displaced, so I'm not going to write it. And then I think it gives us what the volume is. Yeah, so the volume of the metal is 6,600. That's in millimeters. We need to convert that to meters. So if you convert that to meters, you get that the volume of the metal equals 6.6 times 10 to the negative 6 meters. So we can actually go ahead and plug this in. We know all these values. So let's go ahead and plug these in. So weight equals specific weight, which we said it was 9,800, right? Yeah. Yep. And then multiply it by that volume displaced, which is the whole entire object. We just wrote that. We did it in meters, so the units will cancel out. And then we know the tension. We already saw for it. It is 0.11 newtons. Okay, so then once we solve it, we find that weight equals 0.175 newtons. Okay, so now we need to solve for the mass of object 2, which is the metal. So we know that weight equals mg, right? We know gravity, we know weight, and we're solving for m. So let's rewrite this, say m2 equals weight over gravity. So m2 equals 0.17 newtons, and then gravity's 9.81 meters per second squared. So we know that if we put that in a calculator, you need to know this unit conversion. Kilogram times meter times per second squared is equal to 1 Newton. So if we can rewrite that as that, and then get this meter per second squared. We'll get that to cancel out. We'll just be left in kilograms. So this will actually leave us a final answer in kilograms. So put that in the calculator. You'll get 0.0178 kilograms. Yeah, so that's the answer. That is the mass of the metal. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it on the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.